Hello, it's Sunil from NetMath, and you can hear my voice. You can't see me, but here are my hands. And it seems like we're going to be doing some magic with the black tablecloth, and you're only going to be seeing my hands. Specifically, we're going to be doing some exploding dots magic, and mathematics is a magical experience for sometimes when we get surprised, those surprising results and things we weren't expecting, or we want to go down those rabbit holes and see where mathematics takes us. So this is what I'm going to do today. And we have I think it's our 7th webinar. Wow, we're getting really close to the Global Math Week, less than 3 weeks away. But in our 7th webinar, which is 8 o'clock tomorrow night, with James Tanton and myself, we're going to continue on with what happened in webinar 6, which was just this outpouring of enthusiasm from the audience about these base machines that could be anything. And one of the base machines that James spoke about and showed what the result would be if you put 7 dots in was a 3-2 machine. So I'm going to go over that again, and you're thinking, well, why are you going over it again? James did a very good job, and he did. But maybe you had a question in terms of, okay, is that really the number represented by what was put in here? And what James had put in was 7 dots. And I'm going to use these physical counters. Now, like I said, in under 3 weeks, the whole world, and I think we're at almost 450,000 registrants from around the world, 90 countries, Estonia and Rwanda just recently joined, so welcome aboard. But the whole world is going to see some amazing technology from Scholab, and it's going to blow away everybody. But the amazing thing about exploding dots is you can come in at any level. You can come in at zero technology, low technology, and of course high technology, which we hope most of the world will see. And today I'm going to be using no technology. I'm going to be showing you the power and the magic exploding dots with just some manipulation. You know what? And mathematics is this tactile experience, especially for younger children. And I love these because they're two-colored, red on their side, which is perfect for anti-dots, if you know anything about anti-dots in James Tanton's Exploding Dots series. So I really like these counters. They're really cheap and expensive to pick up, and they're fun to play with. So I'm going to put in 7. And I'm going to do the same thing that James did in webinar 6, which was, anytime there's 3 counters or 3 dots, there's an explosion, and it becomes 2 to the box to the left. So I'm going to pick up 3, 1, 2, 3, and boom, there's an explosion, and I'm going to put 2 back. And that's what we have after one explosion in a 3-2 machine. And again, I'm going to pick up 3, and the rule says there has to be some sort of explosion. Boom, and it's now 2 in the box immediately to the left. And this one is just by itself. It's nothing more to do there. It's just going to stay put until we're finished all our kind of explosions. It looks like there's 1 more to go. And I'm going to pick up these 3. Boom. And there's 2 left. And that's what's going to be the code in this 3-2 machine if I had 7 counters or dots. So I'm just going to write the number 211 because that is the code for 7 in this 3-2 machine. You saw 7 go in, and based on this sort of, machine rule, this is what we ended up with. And you might be saying, and hopefully your kids are saying, is that really 7? I mean, I know something like 5 plus 2 is 7, 8 take away 1 is 7. Is this really 7? Does this really add up to 7 physical things that I put in here? Well, that's what I want to go behind the scenes and show everybody today, like sort of pull back the curtains and see what's happening backstage of Exploding Dots. So let me just push this off to the side, and let me bring in my super high-tech dry erase board. And I'm going to sort of just rewind the clock back a bit to the beginning. And I know most of you have now seen the 2-1 machine. In that, if you put a dot here, nothing happens. But if you put a second dot in here, zoom, I believe that's what James says, there is now an explosion, and I'll use my fingers because they're my fingers right here, becomes 1 dot in the box immediately to the left. So anytime you see a dot here, it means the number 2. Well, if you saw a dot here, what number would that mean? Yeah, it would mean 4, because after an explosion of, if there's 2 dots here, that must have come from each one of the 2 dots here, and there's 1 dot left here, so that number is going to be 4. So I'm just going to put in the numerical representations in a base 2 machine. 1, 2, 4, 8, 16. Anytime you're in a 2-1 machine, things are doubling, multiplying by 2. Okay, let's go to a 3-1 machine. Why not? Anytime you see a dot here, it means the number 1, and we're tripling, multiplying by 3, and this goes on forever. 243, 729. It just goes on. But for our purposes, we just need, 4 or 5 boxes. I'm not going to go in sequential order, base 4, or even our familiar base 10. I'll go to something like base 7. Why not? We're crazy. In a 7-1 machine, again, it's only 1. You're multiplying by 7. And, it's a nice challenging way to see if you can still multiply or do mental math. So if I multiply by 7, it's 49. 7 times 49, 343. Did I bite off more than I could chew? Multiply this by 7, 2100, 280, 21. Please check this at home. I think it's 2401. So that's a base 7 machine. We're multiplying by 7. This can be anything. So I'm going to refer anything to mean X. We are now in the powerful X1 machine. Children and students don't have to wait till middle school to see X in algebra problems. They can see X appearing naturally and, in a fun way through these different base machines. So I'm just going to put 1 here because that's every time you put a dot here, it means 1. And just a visual cue. Anytime you see this part of the machine number, it seems to go in there. 3 and 3, 7 and 7, X and X. And again, we're multiplying by 2, 3, 7, and X. So if you keep multiplying by X, and this is a great time for you to introduce this notation to kids. This is not 2 times X. This is just a short, more compact way of showing X times X, X squared. Keep multiplying by that X, X cubed, X to the 4th, and, you can use some fun word, multiply by 7, you're septupling, and here you're xtupling. But the key thing is they got to base X, which is going to explain how this was 7 in some more detail. So I'm going to stay with pen and paper. Just going to put the lid on this. And I'm going to draw 3 boxes. And remember, the code was 211. And we had in a 3-2 machine. Now what I'm going to do is I'm going to divide that by 2 and that by 2, just so it's really clear that we are in base 3/2. So yes, it's the same result, but it's really hard and impractical for me to start breaking counters. So we're in a base 3/2 machine. We're going to be multiplying everything by 3/2. Anytime you see something in here, it's always 1. This always goes here, tells you what base we're in, and then we just keep multiplying by 3/2. 3/2 times 3/2 is going to be 9/4. And I had 2 of those 9/4s. So 2 times 9/4 plus, my 4 sometimes look like my 9, sorry. 1 times 3/2, I won't have to write the 1 in. It's implied. And then 1 of my 1s. Does this going to equal 7? Well, let's see. 2 times 9 is 18 divided by 4. This is still 3/2. I like to show every single step, especially when you're teaching, young students, just do as many steps as possible, and then they can maybe take some shortcuts. We need a common denominator. So it's going to be 4, 6/4, and 4/4. And I'm excited. I never thought I'd be excited about adding fractions. 18 plus 6 plus 4 is 28. 28 divided by 4 is 7. Not 7 factorial. I'm just so excited. 7. So yes, in a 3-2 machine, when you follow the rules, you have the code 211, it actually is 7. And this is kind of, again, going behind the scenes, falling down that kind of small rabbit hole and seeing that it does actually work out when you multiply it by whatever that represents in that particular box, even with this kind of, wonky fractional base 3/2. Now, last thing I'm going to leave you with, and just to remind you about the webinar tomorrow, is I'm going to put 7 back in here, positive side, and there's nothing over here where my hand is. Am I allowed to take 2 of these dots, unexplode them, so they become 3 back here? Is that even legal? What does that even mean? Well, in my next video, or maybe even tomorrow's webinar, we'll explore if that's something that we can do. Anyways, I hope you really enjoyed this sort of, magic of exploding dots video, and we'll see you next time. Bye-bye.